Okay. So good evening, everyone. I'm Satish here from Pregnan AI. So I hope my screen is visible. Let me enable share the screen. Is screen visible now?
Yes, sir.
Yes, sir.
Yeah. So we will be continuing the image processing using Python. In the last class, we discussed about few techniques, basic techniques about image processing. So like opening the file, reading the information, and all those things we discussed, and saving file into different format also we discussed, and then getting different channels like red R, red, green, blue, all we discussed. Then merging the channel also we discussed. So then we discussed about how should we read the data if it is somewhere else, like in a URL location. So we discussed this also. Any doubts in the basic operations? The first thing is you should be installing the package if it is not installed, and then you should be operating. So what package we are installing? We are installing Pillow package. So that is a PIL. So any question? Okay. So next thing is actually like what we were discussing. There are two ways to convert what is called image into grayscale. One we discussed actually. Did we discussed convert into L in the last class? Did we discussed? Let me see. I'm reading image. Everywhere I'm reading the image. Yeah, I'm reading the image. Okay. So one operation what I'm trying to discuss is in image operation model, there is something called a grayscale. So first PIL, image and image operation. These are the submodels in PIL. So one is image, another is image operations. And I'm using this URL lib.request URL retrieve is actually extract the any document or any image from the online. So this is the URL of the image, and the name what I'm trying to say actually it will be saved as the name what I have provided. So this is used to get the image from the it may be image, it can be anything, but like right now, so all we are dealing with image. So I'm getting that image from the internet and saving into my local place as parrot.jpg. And now next I'm trying to open it. So now since it is an image is in color, so I'm opening in a color. So but I wanted to convert into a grayscale. What is grayscale and all those things we already discussed. So again I won't be repeating it actually. So I wanted to convert into grayscale. How should I convert? Image operation dot grayscale in the bracket image. So what is the output? What I'm getting is actually image or in a grayscale, and that I am trying to demonstrate. How should I display? Dot show is the one will be displaying the image. So okay, so this is how I will be accessing and displaying. And if you want to see the what is the type of this one, it will be of type pil.image.image. So it will be of type pil.image.image. So now why I'm discussing this type? Because we need to convert from, see, most of the times what we will do whenever we are operating in the deep learning model, machine learning models, we will convert into 2 or 3 core kind of things. One is pandas data frame, because I will do a lot more things in the pandas data frame if I'm trying to do tabular data. So pandas library is very, very important. And if you are doing anything with a vector or image or something, then I will be converting into NumPy vectors, ND array, or I will be doing TensorFlow vectors, or I will be doing PyTorch, because Keras, TensorFlow, PyTorch is a library I'm using, and that library, other than their thing, they will be comfortable with the NumPy. So I need to convert things into NumPy array. So if you have to do, and another thing is actually, if some certain kind of algorithms is pre-built libraries are not there, so you wanted to write your own equations, or you wanted to do your own conversions, or like logics, or some kind of image processing algorithm or equations you wanted to apply, then NumPy is a very handy. So you will be converting into NumPy, and then there is a function called CussyPy also. Using that, you will be doing lot more operations. You will be doing lot more operations, and then you will be processing it actually. So that we should, for that we should be knowing how to convert any format to NumPy array. So how should I convert actually? Okay, I will do that actually. Like today there was my system got crashed, so I'm using another system. So I will upload that actually, maybe tomorrow. So fine. So what I will be doing, we should be converting into NumPy array. So import NumPy as NP. So NP is a short form. So NP dot as array means like anything NP dot as array means like convert into an array. So that is what I'm trying to do. And in the input, I am reading the image. I'm reading the image and I'm converting. So now if you convert actually, like if you say type I will be in ND array. And this is size actually, this is the shape of the image. What is the 388 is the pixels, one side width, another side is height, another is a channels. How many channels are there? RGB 3 channels are there. And if you multiply together, then that is what is the value you will be getting in terms of bytes. These many bytes will be there. And ndim is actually how many dimension of shape of that vector. So here it is a 3-dimensional, 1 dimension, 2 dimension, 3. So it is a 3-dimensional vector. So ndim will give how many dimensionals you have. So this is the information we'll be getting. And we discussed about, again I'm trying to repeat in the last class, because which is important is lot of people will get confused about like thing what is there in the thing. So here so now let me do using color. Okay. Let it be. See, axis will be there will be x-axis. So this is see, assume that like this is an image. So and see this side is axis. This will be x-axis, and this will be y-axis. I'm not able to write properly. Okay, so it will be something like this. So here it will be 0, here it will be 0, and okay, so this screen is not working fine. Okay, no problem. So this is another laptop, so keyboard is not working properly. So okay, so what I will do, okay, so I will use this one only. So what is that I'm trying to say here is actually, let me add here. See, see, this is how the image looks like. So if you see the image, so image will be this side, the above side is actually, this is the width. So this is the width, and it will be starts from here, this location, it will start 0. So it's like, for example, in this image, if I have to say, let me see here. Mhm. Is it now fine? Mhm. Keyboard is not working. So leave it actually, like let me explain that with the code only. Okay, so this is where it will be 0 and this side is a width. So if I say the width is something that like here, what I'm trying to show here, there was that actually array. Okay. So this is where I'm trying to read an array. So let me show the image. See, this is the image, and if I convert into end image, so this is 388 by 690. So this side is 690. So this is x-axis, this is width. So it will start from this position. This is 0, and this side is actually 388. So and since it is a color, then it will be having 3 RGB kind of things. So it will be having 3 informations like so RG and B. So that already we discussed in the last class, correct? So it will be 3 colors will be there, RGB. So that is what we will be saying. So now next the thing is now how should I convert? We already converted and this is safe. So now how should I convert back into the image? So image dot, so now this is not from NP array, it is from image. So image is PIL library. So from PIL we imported image. So I'm using image. So image dot from array I'm trying to convert. So np dot uint means like why I'm saying uint, because all these pixels will be in the range 0 to 255. So you need to convert, because all these pixels values is the integer values. So I am converting all these values. This is explicit typecasting. So from this point to this point is explicit typecasting. So I am trying to typecast the image. So I'm converting this I, every value of I as a event. Event means like unsigned int. 8 means like 8 bits. So I'm from array, so I'm converting. So from this array, I'm trying to convert into image, and output of this function will be image, and that image I'm trying to show here. So I'm trying to show the image. So now we read the image and we show the image. And if you want to see the type of now after that image, what after conversion, whether it the type got converted, so now it becomes to PIL dot image. So initially it was PIL dot image dot that I converted into an array, and after that, like I can do a lot more operations. Here I'm not doing anything, but we can do that. And then again I'm converting back into image type data, and then I'm displaying. So this is how you will be doing. Like, so when you need to convert it back and then do operations and then do it. So that is the basic things what you will be doing. So any image if you read, then you will be converting into NumPy, because most of the operations or computations is very, very fast in NumPy. So NumPy and CussyPy will be two libraries you will be using to manipulate or perform certain kind of algorithm or processing on the data. So something that, like, if you are in the electronics background, you know MATLAB will be used heavily. So this NumPy and CussyPy are more or less something functionalities are something similar to MATLAB, but not exactly same. But you can do. So it's like when you convert into NumPy array, then you can do all those algorithms, apply in the algorithms, do all those operations, and then convert it back into image. So this is how you will be doing. And another thing is actually, like, I don't wanted to work on the color image. I wanted to make it a grayscale kind of image. Then I will be using that. Like, so another way of actually, like, instead of directly reading the value, I'm reading the image, and then I'm trying to convert into L. So I'm trying to convert into the L. So now I'm trying to convert L. So now what is the shape? So now shape becomes 388 by 690 by 1. By 1 means that is not necessary. So only one channel, correct? So 388 by 690. And what is the dimension? 2-dimensional, because image is 2-dimensional, correct? So this is how it will be there. And if you see that, like, size also reduced. And now after conversion, like what you see, we are seeing the ND array. That is what we will be seeing. So again, same thing, we will be convert back into image and then display. So these are the basic operations what we have done. Any questions here? Okay. The next thing is actually now, okay, we converted into NumPy array, but I have not done anything. So now we'll see that, like, how should we see earlier, like what we have done is actually we used the split command to segregate RGB channels. But now how should we do here? So there is first you convert into NumPy array, then so channel, see, first is actually the width, then height, and then the channel. So now what I'm saying, colon. So this becomes ND array. Array is like something like a list or tuple or something that, like, I will be slicing something similar to that. So I'll be the slicing will be same as the list and all those things, correct? So means like, since for first dimensional, when I say colon, means like all width, everything will be considered, comma. Then second colon means like everything about the height I'll be considering. Then comma. In the last one, there are three things are there, RGB channels, correct? So I'm looking for only 0. 0 is the first R. So next one means like G, 2 means like still 3 channels are there, no? 0, 1, 2, 3. Means like by using the slicing, I can get the extract the RGB channel. It is pretty easy. So I am able to extract certain channels. And if you wanted to convert only R, so same thing, from array, I'm just converting R into image and I'm trying to display. So something same, because I extracted image, R channel, then I'm displaying it. So I'm extracting blue channel, then I'm converting back into image, and I can do. It's like, so what I'm trying to show is actually, like, you can convert into NumPy array and then all do operations. Like, so then you can convert it back. So that is how you will be doing. So any question here? So I have shown you using the function. And now if you have to merge it, actually, how should you be merging? So you'll be using ND array, NumPy array to merge it. So there is a function called dstack. Dstack is actually, I'm trying to stack. So I'm trying to stack at the axis. Which axis? Actually, third axis. So I'm trying to give what are the parameter? So RGB parameters individually. np.dstack, I'm trying to stack. So how I'm trying to stack in the as a third dimension. So third dimension I'm stacking. It's like first two dimensional will be first value, then second vector two dimension, third axis. That's the way we need to stack the array. So we are stacking, correct? So when we see that image, there will be R channel, then G channel, then the blue channel. So like that, I'm trying to np.dstack. So I'm in the bracket I'm giving what all things you need to stack. So R comma G comma B. So now what output we will be getting? RGB. It's like it will be having all three channels. So now again from this array, ND array, I'm trying to convert it back to the image. So I am image. So from array, so I'm trying to pass that, and then I'm trying to show. So this is how you can segregate using NumPy array, and you can merge using NumPy functions, and then you should be converting back into the image format and then displaying. So to segregate, I have used the splitting of the slicing of the array. So colon comma 0 1 2 3, and while merging I used NumPy array function called dstack. So stacking together. Any question?
No, sir.
Class open.
Okay, Char.
Fine. So next, what else we can do? So we already done this, correct? So we converted into is my voice audible, correct? So we converted into image, all those things. These are basic things we have done. So now what I want is something that like I wanted to create an image. So I wanted to construct an image. So this also provides what is called NumPy provides, image function provides. You can construct a image. Construct means like you take two image or do some kind of operation and then construct a new image. So I am trying to construct a image. How to construct? The function called new. So there is a function called new. So that function will be used to create a construct a image. Construct is like you know what word, correct? Constructing a building, constructing a image. It's like drawing or like creating something. So the function is image.new. So now I am trying to give the what kind of image, because image, it can be grayscale, it can be RGB, all those things. Now, so we need to tell what kind of image I wanted to construct. So that is the RGB image I am trying to construct. And next is I need to mention actually image also has what is thing actually. One is a mode. So whether it is a grayscale or color thing. The second one is what is the width and what is the height, correct? So that is, you need to mention what is the width of the image and what is the height of the image. So I am trying to provide the image width and I'm trying to provide the image height. So I wanted to create based on the some image. So what image I have read? So I have read two image. One is actually color image. Image 2 is actually black and white, gray scale image. So I have read it actually. So now what I am trying to say, my width should be twice of the image 1 width, because I need to add 2, correct? So width means like this direction. Width is this direction. I wanted to put first image and next to that image. Means like width should be width of 2 things, no? Because I wanted to stitch together one after other. So that is the reason. You can stitch to in height wise as well. First and below, first and second image, or you can stitch in horizontal also, or you can overlap. It is up to you how you want to do. But here my intention is actually first image and then I wanted to put the second image. So something that like, okay, for example, in the photo shoot, no, they will take what is called person boy's image and girl image and then stitch together. So you can do manually, like you can do programmatically. You take one image and you take another image, you stitch together and create another image. So this is how you can create. So now I am trying to create a new image. and the mode is RGB color image. And now I'm saying that like width is twice the width because I need to stitch one next to next, and height is both height is same. So I'm trying to save. So this is how I'm trying to create the image. So now this is the something like I have created a empty list by providing information, because I am not given the value of the image, correct? So I am not given the pixel values there. What I have given is actually the framework of the image is created. Framework means like in terms of size and in terms of mode, color mode actually. Now image dot paste is a function. There I'm saying that like where to paste. So I'm saying image one you paste at 0th 0 location. 0th 0 because like I know that like correct now which location I should be pasting, correct? So I am trying to paste that image. So this is where I wanted to paste 0 0. So next is actually second image, but second image I don't want to paste here. I wanted to paste here. So means like this width is actually the width of the first one, and this value will be 0. So here, so width and 0. So from this is 0 0, and now here I need to go, means like I need to cover this whole width, and this is 0th location only. So I wanted to switch to put another image, paste image from here. So image width, first one image width and comma 0. So now I want to save that image as something JPEG, and then I want to show that image. This is how I'm trying to stitch together. And what would be the assignment for you? Take two image and now you do vertical stitching. So then vertical stitching using new and paste. So create an image. First you should be reading the image. So what is assignment? Assignment, the thing will be, let me write here. Assignment meant 1. So read a boy image, then read a girl image, or you can say both boy, both girl. It is up to you, whatever you say. Two different image. It should not be same image. And of same shape. So next, same shape size means like it should be of same size. Or if even if different size, then you need to know what is how to calculate. So next actually stitch. So stitch. Vertically. So and save as JPEG and then display image. So this is a task. I want image like half black and white, half colored. That is also possible. No? This is what we have done. Half black and white, half colored. So this one is black and white. So, and if you want to do half black and white and half color, then you need to do a lot more computations. So a lot more computations you should be doing, because you should be taking this image and splitting into two slices, and one portion you should be converting black and white, another portion you keep same and then stitch together. Yeah, that is also another assignment. You can do that. So I will give that is also another assignment. So assignment 2. So read one image, then split, convert it into numpy array. Now take half of the image, half of the image. So take half. How you take, you know how to split and all those things. Like, so you take half of the image. Next, what you will do? Convert the old image to grayscale image. So old new full image to grayscale. Take half image, make it half image, and save this actually. Save as an image. So now convert the full image into grayscale image. And now take other half of this, other half. How should we do? Same, convert into NumPy array and take other half and save as image. Save as an image. Next, now create new create image. Stitch these two. Stitch these two halves. So this is what is the second assignment. So how should we do? I am given the hint here, so you should be able to do. So take one image, convert into NumPy array, make it half. First half you put it and then convert back into image and save it. Then take the old image again, convert into grayscale, and then take the second half of that and save as image. And then you start creating new image and take this first image, paste first image, then take second take image, paste second image. Then you need to demonstrate half black and half white. So that is the second assignment. Any doubts? Any doubts in the first and second assignment? Interesting? Is doubt audible? Am I audible?
Yes, sir.
So this is the two assignments I have given, and by doing these two assignments, you will be touching all the things what we have discussed right now. Fine. So next one is actually I wanted to, okay, here the stitching one after other is there and all those things is there. Like, let me do that actually. But here what I'm trying to do actually, like here I'm trying to stitch actually, but before stitching I'm trying to resize the image. So for example, if you are taken an image, one image size is different, another image size is different, so you can't stitch together, correct? So you wanted to resize them actually. So how should I do resizing actually? See, first line is reading the image, then showing the image. Second line is reading the image and converting into grayscale, and then I am trying to show. So first color image, then black and white. Then what I am trying to do? I am trying to first image I wanted to resize. So what is the size I wanted to? 426/240. So that is what I am trying to do. So 426/240. I wanted to resize the image, and second image size also, like, so first image size is same as the whatever, like I'm getting the size and I'm trying to store the first image size, and second image size also I'm trying to show the same thing. Now what I'm trying to do is actually I'm trying to create an image, new image of twice this width and the size of the first one. And now what I'm trying to give is actually I'm trying to give the values 250/250/250. This is what something that, like, I am trying to use some kind of a information. This is forget about, like, actually this is what I'm trying to give some kind of a rough kind of values. So without this also is fine. Now what I'm trying to do actually, I'm trying to paste first image here, and the second image I wanted to convert, so the size of that. So when just wanted to just paste it, so now I wanted to put that image in that location. So then I wanted to save it. So first image and second image. So that is what I'm trying to do. So if you wanted to resize the second image also same size, then you should be resizing the second image. If second image is of same size, then no need to do, or else like you should be resizing it. So but here what I have done actually, I have not resized it actually. So since I pasted with the because of that actually, if you see here actually, this here I'm getting the full image, but here the image is got cut because I'm not resized. So this is the intention here actually. I'm pasting here with the only that much space. Like when we give only that much space, then it is something that like an image will be cut. So because one image is bigger, one image is smaller, but I am trying to take only the starting. So if I say something that like width is this much and something that like no, it's like I will be, since I will be only taking the top portion, whatever the portion I wanted to take. Means like see something that like I have my frame is fixed, but another my image is big, means like I need to cut the frame, correct? So here I have cut it, but one image I have resized, means like compressed. I programmatically I made fit into the frame. The second one I cut the image. So second one, because I have not resized it actually, but I have cut it actually. That is what it is visible. So you see this whole image, actual image is this much. So actually is this much image. But while stitching, I have taken only small portion of that. See, this is not a full picture, no. So this below portion is automatically got cut because 0 is from this point portion. So if you say that like if you take only this much, then remaining will be cut. And if you take only this much, the remaining below will be, because it all starts from this location. It is not starting from this location. So it is all starting from the right, the left and rightmost corner. So means like whatever, if you are taking till this much, so the remaining will be cut. So if you see here, actually there is no remaining portion. It's got cut, but it is there here actually, because here the image is got compressed. If you see the size actually, so one is resizing I have done, another is not I have done resizing. So when you are trying to stitch two different images, so you should make sure that like both of same size. You should be using function called resize. Any question? Any doubts? So understood or not understood? No response. Okay. Is it understood?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
So the next one, what I'm trying to do. So now this is a basic things I done, but now I wanted to do some kind of a beautiful things. So now let me take, this is one image, and this is I wanted to put one image and another image, like some blending of the something. No, so you will mix or merge two images, correct? So that is what I'm trying to do. So something that like we do, no, one image inside another image or something that like, so something that they will do. So or like you wanted to put your photo and some other like behind is actually your college photo or your house photo or some beautiful location you have gone and they wanted to put, you can do that actually. So one image and another image, like I'm trying to mix some kind of play around that technology. So not using the Photoshop kind of tools, but using the programmatically. So these are the some of the basic things we can do, correct? So I'm trying to do that actually. There is a function called blend. So this blending is actually merging or combining two things by giving certain weightage to certain image pixels and certain weightage to certain pixels, because one image means like certain pixel, another image means certain pixels. I am trying to mix these things and create some kind of a combination kind of a image. So that is the objective. So this is actually, here I'm trying to paste another one. So here also I'm trying to do, but like I'm pasting there actually. Like if I had an overlap also, the same impact will come, but I'm putting next to each other, something that like, so that like I will see the clear images. So now how should I do that actually? First I need to read the image, correct? So I'm reading the image. So first is house image. So this is the house image I'm trying to read. So you can read anything. So you can read your college and all those things. So next is I've read the parrot, then I'm house. So I'm trying to make both images of same size because I wanted to make. So I'm resizing both image and then I'm converting both images color. So I wanted both has to be color, correct? So image one convert into RGB, both RGB. Now alpha I'm trying to define. So means like what is a weightage for each image? So I'm trying to define that. Alpha is a weightage. Like I'm trying to do 50-50 weightage both. So you can change this alpha and then see. So what I'm trying to image dot blend first image, second image and alpha. And this is a blended image. I'm trying to save the blended image and I wanted to show the blended image. So what is the assignment for you will be, you take your photo and you take your college photo and then you blend it and create, save it and share to me. So assignment will be assignment would be assignment 3. Take your photo, then take your college photo or your house, whatever your interest. Photo. Now blend and create new photo and save it and show it. So then share the photo, like no need to share, so just keep it. Or you wanted to showcase your work, you can showcase to your friends. Fine. So this is the assignment. The third. So because this is also, you should be knowing how to blend it. Any question? Okay. So these are the basic things
No,
that
sir.
we understood. Like we open the file, close and did some kind of resizing. These are something. So other than that, like there are so many other basic operations. So construction is done, resizing is done. So rescaling, cropping, rotating, and flipping is also other kind of operations we should be learning. So now size and resizing we have already done. So again, I'm trying to showcase. So how should we do resizing of the image? So I have read the image and I wanted to size. So 690 by 388. I wanted to make it 6426 by 240. It is anything you can do. There is no such thing. So you and then you wanted to showcase the size and you can showcase the image. So I have just mod. So much like, so now if you wanted to change your photo, you take your photo and you wanted to make it any shape. So or like a bigger photo, smaller photo, or any way you wanted to do, you can do it actually using the programmatically. So you take 5 by 8 and you want to make 14 by 16 bigger kind of image, programmatically you can take it, you can do it. So there is no necessary to be do Photoshops. Any questions here? So that is can be your assignment. So you can, so you know photos have some specific shapes, correct? So 5 by 8, 8 by something is there. You know that photographer guy will say, no, the passport size is something, other size is something, other something. So you take one photo, then you can create your you check with what is the size of the passport size and frame kind of size on different frame size. Then you can create using resizing. So you can create your photos passport size and all different size. Correct. So using programmatically, you can try out it actually. That is bonus assignment if you want to do play around with that. Any question? Okay. The next is
No, sir. No, sir.
resizing is done. So let me see. Thumbnail also we have done. So and another, there are so many functions are there, anti-alias and all those things. So these are actually like remove the noise, clear kind of things. I'm not going there actually. These are the what is called image processing terminologies. So intention here is actually I wanted to create a more and more clear kind of images. So this BiCube is actually like, so this is whenever when trying to use scaling the image, when we try to resize or make up or make down or something that like, so when we try to do that actually it does by default some algorithm. So no need to write an algorithm here. So there are so many algorithms are there. So you can specifically pick up certain kind of algorithms like, so PIL supports, these are the bicubic algorithm. So because when we do scale up or scale down or something, so there are so many algorithms will be there. Let me come. I'll show here only what all the algorithms are there. So it by default it will use one kind of algorithm. So let me show that like what all the algorithms are there. These are the algorithms are already pre-written, so you can use it. But if you want, you are not satisfied with this algorithm, then you wanted to apply your own algorithm, then what you can do is actually while doing resizing of the image, you need to convert into NumPy array, and then you can do the rescaling of that image by applying that different algorithm. So these are the algorithms: adaptive, affinity, anticlo, bicube, bilinear, box, cubic. So they're all are different kind of algorithms. So these are the algorithms already there. So you can use that. But if you see that like, okay, I wanted to write an algorithm, then convert into NumPy array. So if I have to see now, let me show you that like NumPy array. So it is very fun kind of thing. So you can play around with 1 minute. Where was that? So okay. So let me go back to here. Now I'm trying to read again. So I'm trying to segregate again. So now I'm trying to convert, correct? So now let me paste here, let it be. So what I will do now, I will do take this R. R is the something, no? So now I will say R equal to R star 2. Then show the R size of R. So now I want to do, I wanted to check the shape of the R. So what was the initially size of the image? 388 by 388. Okay. So 388 by 16. Let me do. Now I have did multiplication by 2. Let me convert it back into the image. Just I did multiplication, correct? So I just wanted to see the thing. Now what I wanted to convert into this new R. So I will say this is R. Okay, let me this R, and I wanted to show. See, okay, how was this image earlier? This was R. So I just multiplied. This is how it looks. It's like, so just by doing some number, something, you will be getting. Like, let me again read it back. Let me show here. Let me read it back again. See, you should manipulate the values, so the whole image is get manipulated. So you can do something. Like, let me show one more. So one more operation. What I will be doing. R is equal to, I will say everything instead of multiplying by 2, what I will say, multiply by 2, and I will say modulus 255. Okay. So much like intention is actually like you can play just like a number, correct? So let me show here how is that looks like. So this is how it looks like. So by doing, and you can take, you can do a lot more operations. Like you can say that like I wanted to drop off the values below above 128 or something that like all those things. Any manipulations you can do with the numbers, and the image got impacted. So you can play around that. There is no worry. Take a photo and do all those combinations, like remove a filter, like just give the mean value, or like remove higher value, or multiply, division, all anything. Then you see that like what is the impact of that on the image. So then you can convert it back and you can show. So this is all things you can do. Because why I'm trying to show now, when you convert it to NumPy array, all the mathematical operations, all the algorithms, all the calculations, whatever you want to do, you can do it actually. And then we can convert it back into any image, and then you can display. So that is the thing. So if you want to write your own algorithm also, you can write your own algorithm of manipulating the values. Means like if you wanted to enhance or remove the contrast or remove whatever it can be. So, but there are some predefined libraries are there, like, so you can use that. So if you are not using while rescaling or scaling something, by default library algorithms will be used. So you can see that, like, if I do with this one, let me again go back here. If I use with this algorithm, how it looks like. If I use with another algorithm, how it looks like, you can do. So scale is actually, I'm trying to scale. So in when I'm trying to say scale, so when I say size, I should be giving the size, width and height. When I say scale, so I will be saying that, like, okay, make it to 75% or 80% or 90% or 10%, because I wanted to do that. I don't do, I proportionately, I wanted to compress, like make it smaller. Like, so if I say that, like, I want to do 50%, so if I say 50%, then the image will be further reduced. So the size, no, I wanted to something that like only 15%, so the size will be automatically shrink to the 15%. So you can play around. So now something that, okay, no, it is not good shape, so I wanted to make it 25%, you can make 25%. So it's up to you. So just, and you can play around with the different algorithms and see that, like, which algorithm is scaling is good or which is not giving the correct, all those things you can play around it. Any question before we move on to?
No, sir.
Okay, so is it interesting, fun to play with image? So I want you should start playing with the image. That is the objective. So
Yes,
don't just play around with this algorithm, play around with and see, convert, and then mix, match, blend, lot more things. Then only you will feel like the power of Python. Or else, like, you won't be seeing that thing. Fine. So okay. So next is expand. So I wanted to expand. When trying to expand, actually, I'm trying to say that, like, what is the frame? So now when I'm trying to expand this image, but this is an image, but I wanted to expand. So image will be same, but background information will be created. So something that, like, I wanted to create a frame to that, actually, I wanted to create a frame. So this is the image. And that's like, if you wanted to create a bigger kind of a frame. So what is that I'm trying to, this is the image, and I'm trying to make expand, I mean, it's like extra thing, the border of that. So width side 10, 50, this side is 50, this is a 50 only, the height side 100, this is 100. You wanted to make, okay, no, this is too much good, not that good, so you will make 50 by 50. So means like my frames will be 50-50. So means like it looks nice. Okay, this side is extra. This is something that like a padding in the convolution neural network, what we discussed. So something like a black background kind of things. Like, I'm trying to add the padding or a framework on that, actually. So this image. So okay, this is too much. Actually, I wanted to make it the frame too nice. Then I will make 25 by 25. So maybe 25 by 25 looks nice frame. So you can create your frames. So this is how you can do it. So now it looks nice, correct? The frame. So you can do that also for your photo, and then you can check it, actually. Like, it's like now with the programmatically you can create. And if you write that, like, actually, if you give one image and you can write, actually, like, okay, you create a frame, you reshape the things, then create a frame, color it or do it, all those things. So once you done, much like if you run this program, automatically all kind of shapes and dimensions and all the pictorially whatever you want to do, you can create it. So that is what is the one assignment or one task you can take it, like the mini kind of project, or like one person do one thing and stitch together, and you say that, like, okay, you give one image, then suddenly all the things will happen, and all different kind of images, shapes, background, all things will be dumped as a multiple images. So then that you can showcase your college and say that, like, okay, you take a photo, you give me a photo, I will create all shapes and I will color something and I'll give to you. So that will be fun kind of a project, so you can play around with. Fine. Okay, next is a cropping. So you wanted to, cropping is actually means like I wanted to cut the image. So like here I need to mention which portion I should be cropped. So this is the left side, upper side, right side, lower side. It's like how much I wanted to crop. So crop is like pixel wise. So 50 pixels on the left side, 50 pixels, like see, this is the left side, 50 pixels I'm cutting. So if you take this image, so this image, so first 50 pixels I have cropped. Then what I'm trying to say, upper, how much? 20 pixels, means like from upper, like, so here 20 pixels will be cut. So that is what is I'm trying to say. And the right size, how much I want to create? 200 pixels, like, so 200 from here, the 200 pixels I want to cut. And the lower I want to cut actually 250. So this lower I want to cut 250 pixels. So that is how. So cropping is like I'm trying to how much I wanted to segregate. Like if, for example, if your image is there, in image a lot of things is there. So I wanted to remove off the all other portion. Like, so for example, you have taken a photo, but lot of background is coming actually. Like I don't want to do that. Like then you know that, like, okay, play around with and remove all the background kind of things and keep it the whatever where exactly the frame where your proper picture is there. So that is how you can do the crop it actually. Manually you can, programmatically you can crop it and you can do it. So any question? So why we need to do all these things actually, like when we do programs, no, when we need to feed the images. So sometimes now when we are taking a image, we have taken something extra kind of things. Like I don't need actually, I want only the proper, like if I'm trying to take an X-ray, I wanted a proper X-ray, but like I don't want the remaining all the other information or something, like I don't want anything other information. Then you say that, like, what is you should be dropping upper, this left side, right side, downside, and you take only the pure X-ray image, and then you create those images and only you feed those images to the models. So that is the objective of this one actually, because in X-ray there will be something like written in the top, maybe something written in the bottom, or like something like that. Now, so I will be cropping all those things, only pure X-ray image I'll be taking and then I'll be displaying. So this is the objective of the crop. So you can select whatever you wanted. Any questions? So function is dot crop. So there's the part of image. So these are the basic operations what we are trying to study. So any questions? And the same thing is there. So this is one crop is from image. Another crop is also part of the function called image operations. So image operations also there is a crop is there. So here I will be trying to say only width wise how much pixel and height wise how much pixel. But here I need to give left, upper, right, lower, all those things. But here how much pixel upper, the width wise, how much pixel, the height wise. So I am trying to give that much. So to be removed. So you both you can use. So use to do the operations. So any questions? Okay. So next, let us move on to. So another thing is actually like you can crop it, and I wanted to take and paste it. So I am trying to create an image and pasting. So intention here actually, I am using the cropping and I'm also pasting it actually. It means like, for example, you wanted to have this picture, and this picture, here you wanted to put your what is called your college picture. So for example, your photo, and you wanted to put a college photo here. So then you can crop or like resize that actually, and then you put here. So that is the thing. So now I want you should be doing that actually. So something that like your picture, this side your house picture, and this side your college picture. That is another assignment you can play around. So you will come to know that like how to placement has to happen, how should cropping of the has to happen, how to rescaling has to happen. So now here one above that I have done, but like this position. So where should you put actually? So this corner you should come to know, or like this corner or bottom corner, then paste one side college, one side thing, and then you show that like my photo, my college, and my house, something like that. So that is the thing. So any questions on the cropping? Okay. The next operations what we can do is actually rotate. So rotating the image. So you read the image and then rotate 90 degree, and this is algorithm again. So what algorithm you can use? And now by doing, see, by expand, when we expand means like whether the image should be expanded or not expanded. If you say one means like it is not expanded. So now I wanted to rotate the image. So this image 90 degree I rotated. So how is the initial image? Initial image was something. Where was it? It was something like this. Initial image was something like this. I have rotated to 90 degree. So 90 degrees this way. So this is clockwise, anti-clockwise. So you will be rotating the clockwise. So now the image was something like it was here. So that I have rotated. So in the direction of anti-clockwise. So 90 degree. So I'm trying to convert into 90 degree. Any question?
No, sir.
So all these rotate, all those things you can be is a simple. So rotate degrees are there. You can be 90 degree, 60 degree, 20 degree or something. So if expand, so now let me do angle actually. Let me do an angle also. .45 degree. So this is how it looks like. So nice kind of picture, no? So something like a frame with some kind of things. So you can do that also. So fine. So another function is mirror function. Let me show. Mirror means like mirror image, creating a mirror image. So you can be creating, you know what is a mirror image, correct? So I can create the mirror image. So this is the functions. Then flip is actually like horizontal flip, vertical flip, all those kind of things. Like, so I wanted to flip. So I wanted to flip actually, and mirror. So you want to see flip and mirror. So these are the basic operations. So any question? Okay. So these are all the basic things you can do. So I think we will end here. So next class, what we will look into, so some kind of little bit like a deeper into the what is called processing. So deeper into the processing is like I am trying to modify or change or do filter, like some kind of a filters I wanted to use with the color, the images. So that we'll discuss. So this is till this actually all the basic operations are done. So now here onwards, we will go a little bit deeper into the image processing. Any question? So how to do image
No,
enhancement,
sir.
image filter, all those things we'll look into. So for here onwards. So if there is no question, then we'll end here. Thank you. So is it,
Thank you.
are you able to follow the pace, or I'm going slow or fast? How is it? Is okay, no? So for EC students, I think they know a lot of things, but what about the CS students? They are able to understand?
Not fully. Sir.
Hello?
Yes, sir.
Okay.
Yes, sir.
So EC students, image processing is done for you, no? Or it's not done? Let me stop.
Done, sir.
But you used to do